Here's number 17 out of 1.4. We have a function, f of x is equal to a piecewise rule of 1 over x for all x less than or equal to 2, and 4 minus x over 4 for all x greater than 2. The question we're asked is, does this function have a tangent line at x equals 2? So this question really boils down to the tangent slope. If the tangent slope coming from the left of x equals 2 is equal to the tangent slope coming from the right of x equals 2, then we're going to have a tangent line. This is especially important on a piecewise looking function like this, where we would want that tangent line coming from the left and coming from the right to eventually meet and become the same tangent line as they approach this x equals 2 spot. So we're going to do that by checking both a left side limit and a right side limit to give us the tangent slopes on either side. So let's begin with the left side limit. So we have a limit as h goes to 0 of an f of 2 plus h minus f of 2 all over h. And let's begin by plugging 2 plus h and 2 into our function. So this is a limit. Oh, by the way, this is the limit as h goes to 0 from the left. 2 plus h goes in, we end up with 1 over 2 plus h. And then minus a 2 goes in, we end up with 1 over 2. And then this is all over an h. Let's simplify by combining the two fractions in the numerator and finding their difference. We need a common denominator. It's going to be the product of the two denominators, 2 times a 2 plus h. So this 2 plus h needs multiplied by a 2. We'll do the same to the numerator. This 2 needs multiplied by a 2 plus h, so we will multiply the top numerator by a 2 plus h as well. And then let's begin to simplify. So this is a limit as h goes to 0 from the left of a 2. And then minus a 1 times 2, so minus 2. And then minus a 1 times h, so minus h. And then that's all over the common denominator of 2 times 2 plus h. Then instead of making another complex fraction where we divide everything by h, I'm going to multiply by a 1 over h, which is the equivalent. Anyway, okay, what do we simplify now? 2 minus 2 makes 0. We see a negative h as a factor in the numerator and a positive h as a factor in the denominator. We can cancel that factor of h, leaving just a negative 1 in the numerator. And let's write our new limit statement after this. The limit as h goes to 0 from the left of a negative 1 left in the numerator and a 2 times 2 plus h left in the denominator. So as h tends towards 0, this expression tends towards 1 over 2 times 2, which is negative 1/4. So the slope of a tangent line coming into 2 from the left would be negative 1/4. The slope of a tangent line coming into 2 from the right we'll have to find separately. So let's begin there. The limit as h goes to 0 from the right. Let's plug in an f of 2 plus h minus f of 2 all over h. So what will this look like? Well, it's going to be another limit statement, obviously. We put 2 plus h into this function, we get 4 minus the quantity 2 plus h, and that's all over the 4. Minus, we plug in a 2, 4 minus 2 would be 2 over 4, and I'm going to leave it as 2/4 rather than call it 1/2. That way I don't have to find a common denominator, put all that together, and then this is all over h. So what do we have here? This is 4, this is minus 2 minus h, and then since we have a common denominator here, we can just kind of bring this up as minus 2. So this numerator, 4 minus 2 minus 2, that all turns out to be 0. So let's go one step further. The limit as h goes to 0 from the right, we have a negative h left over there, and then that's over the common denominator of 4. And then instead of dividing this all by h, again, we're going to multiply by 1 over h, and we probably notice that the h's cancel, leaving us now with a limit as h goes to 0 from the right of negative 1 over 4. There are no more variable h's in there, so this is just the limit of a constant, which is the constant negative 1/4. And let's take a look. Our left-sided tangent slope and our right-sided tangent slope both match, and so that means we do have a tangent line at x equals 2. So we'll say yes for our answer. And what is that tangent slope? that tangent slope is -1/4. So hopefully that helped with this section of problems.